Once again, this call is being recorded and we place our recordings on our YouTube channel. If you don't want to be recorded, you may want to drop off now. And with that, happy Friday and thanks for joining for another session of Azure Power Lunch. And today we have a very exciting topic. This is the AKS CNI overlay networking for AKS, Azure CNI overlay networking for AKS. So as usual, we're going to talk about why we need the networking support in AKS. As some people, it may be obvious, and we will look at different models and how CNI overlay is different, what it brings to the table, and have a quick short demo uh, with that. So please feel free to ask questions. And if there are any questions in the chat window, uh, I will appreciate if you know someone on the call can uh, read those and ask them.
I just think I'll get now. Yeah, please feel free to
Thank
write
you.
on the chat, guys.
Thank Allah. Thank you very.
Yeah, sure.
Okay. So this is the. So first of all, just a quick step back. AKS is Microsoft managed Kubernetes offering. We make deployment and management of Kubernetes. Azure makes deployment and management of Kubernetes cluster simple, but you don't have to worry about running a lot of scripts or anything. You can just go to the portal or CLI with a few simple commands. You have a Kubernetes cluster up and running in a matter of minutes. Okay. What is a Kubernetes cluster? It's a set of nodes um, that runs your application in the form of pods. Your application may consist of one or more pods, and those applications, or what we call microservices, may talk to each other. Okay, with that, there is a set of master nodes. And in the case of AKS, these are taken over by Microsoft. You don't have to worry about the master nodes, and those master nodes are responsible for the management task and all that. Okay, so that's a quick 1 minute introduction of AKS. Why you need networking? Because these pods, they need to communicate to each other. Since they make up applications, those applications may need to talk to each other. That's why you need a way for packets to go from one pod to the other. Okay, and so there are two models that are available prior to overlay. One is called Cubenet. This is the default built-in model. If you don't specify any model, that's the model that is deployed. And what it does is every node in an AKS cluster gets an IP address from the subnet where it is deployed. Okay. And the pods that are running on those nodes, they get IP address from a different range than the subnets. So this is basically a kind of a different IP address range, a CEDAR range from which it gets the IP address. It's not from the network range. And the way how the communication work, you have to set up routing and netting. That's your responsibility to set up. With AKS, just keep in mind, though it's not obvious, when you are deploying it, behind the scene, it is doing that. So when you deploy AKS, it does deploy that UDR and netting infrastructure to support this communication between pods, which may be living on different nodes. So that is done by Azure. That's why we call it a managed Kubernetes when Azure is deploying a managed Kubernetes cluster. And there are some limitations that comes into picture. First of all, there is a slight latency when because of this hopping using UDR and all in the case of Kubenet. Second thing is there is a limit of 400 UDRs per subscription. That's why you cannot have more than 400 nodes in a Kubenet cluster. Okay, so that's the thing that is some of the things that you have to keep in mind with Cubenet. Okay. Then comes the Azure CNI networking. That's uh, what it does is you have nodes and you have pods running on it. Not only nodes, but pods also get an IP address from the subnet where the cluster is deployed. For a minute, that looks great. Okay, yeah, I mean, now you have each pod has a subnet, they can communicate to each other, just like VMs, wonderful. No need to have a networking infrastructure. But think of it. Now you have to design your network carefully. You have to take into account what will be your future growth. Let's say you deploy, you have a /24 subnet, you deploy an application, and you thought the 256 IP address will be sufficient for that, but that application is growing, more microservices, more pods, more nodes are being added, and suddenly you come across IP exhaustion. Okay, so that's the challenge. And that's where this overlay network comes into picture. Think of it, it is kind of looks to me, it's a CNI V2, best of both worlds. CNI and good features of both CNI and Cubenet combined. First of all, you have kind of a similar to Cubenet. Each node gets an IP address from the subnet, you know, and but at the same time, pods gets IP address from a different IP address range that should not overlap with the subnet IP address range. So that's the I mean, that's kind of a similar to kubenet. Second thing is, which is why the overlay comes in, there is a infrastructure that is created as a part, networking infrastructure that is created as a part of this add-on, which creates an overlay network for pods to communicate to each other if they're different nodes or on different nodes. So there is no need to deploying the UDR and all that fancy stuff. No, no need. All of it is taken care of by the this overlay network that is part of the Azure networking stack. You know, so that does take care of that. And with that, once there is no UDR limit, you can have up to 1,000 nodes in an AKS cluster. Just keep in mind, any communication that is happening from outside, uh, the node IP address will be used for the outside communication, when pod is communicating outside. Okay. There's no need to do the custom routes and all that stuff is now out of the picture. Okay. Any questions? Okay. So as you can see here, um, kind of similar to kubenet, but once again, the Azure with the Azure networking piece is there, overlay network is there to address the issues that you have with um, with CNI networking. Okay, so that's a picture. I hope that explains what I was describing earlier in a more kind of in a better way, in picture versus 1,000 words. So let's take a look at this. First of all, you have a 10 dot, oh, sorry, um, a 192.168.1 dot 0 slash 24. That's your um, subnet where you are deploying the AKS cluster. Okay. As you can see here, each node is getting an IP address from that cluster. Okay. So you are getting like this, the first node gets .4 since the first few IP addresses are taken are reserved for Azure and vice versa. I mean, moving on. So each um, and so on. So each node is getting one of the IP address from that particular subnet. Okay. And then Each node gets a /24 address space. And by the way, you cannot change it. At this moment, you cannot change this address space. Like you cannot change that /24. It will be /24. So each node gets space for about 250 pods. If you have /24, you can do the math, it's around 250 pods. So you can create 250 pods on each node, and each node, for each pod, and each pod will get the IP address from that particular address range. And you can assign this address range when you are creating the cluster. So what it does is it takes that range /24, assign it to first node /24, the next one assigned to the second node, and that's how, as you can see, they are creating those pods. And then you see this overlay network that is there, that is built in to communicate. No need to creating UDRs and NATs or that expensive stuff to cause any performance degradation. Now it's all taken care of by the CNI overlay uh, networking add-on. Okay, that's that. And any communication that is happening outside, you will use a NAT, Azure NAT gateway or a load balancer anytime. I mean, everything stays the same. Everything else stays the same. I mean, you want to access any services in the AKS cluster, you will have to use an ingress controller. You know, so same thing. There is no change there. The big change here is that there is no need for having any UDR or NAT gateway deploying because this add-on is taking care of that. Okay, any questions at this moment?
Nothing on the chat, Naveed, so far.
Okay, thank you. Okay, so that's that. Um, so So, as you can see here, 250 pods per node and 1000 nodes per cluster. Just keep in mind, you can have multiple clusters in the same VNet as long as they are in different subnet, and they can use the same pod-based address space. So there won't be any conflict because even if they are communicating across cluster, the IP address that will be used will be the node IP address. It won't be the pod IP address. So just keep that in mind. Okay, so you can have that. Okay, so let's see. So let's compare Cubenet versus Azure CNI Overlay. As we talked about, both supports 20 to 50 pods per node, but now with CNI Overlay at this moment, which is currently in public preview, 1000 nodes you can create with Cubenet, only 400 nodes because of the limitation that we already talked about in regards to UDR. Okay. Second piece, network configuration. Simple. No need to have to deploy UDRs or NATs. All of that is taken care of pod to pod communication on different nodes through this overlay network. In the case of Cubenet, that's not the case. It's complex. You have to do UDR. And the thing is, if you are deploying a managed Kubernetes AKS cluster, all of those details are hidden in the case of Kubenet. That's why it's not visible. Otherwise, you will have to do all that infrastructure. Okay. Pod connectivity, it's comparable to VMs on the same VNet. So that's an advantage. Very fast. On the case of Kubenet, there's a slight lag because of the extra infrastructure that is added. And it can become large if you are doing a lot of communication. In terms of network policies, Calico and Azure network policies are supported. Kubenet only Calico policies supported. And finally, both are supported for Linux. CNI overlay at this moment is in preview, and they are only supporting Linux at the moment. Okay. And in regards to IP address planning, I have already mentioned that if you are just going with the Azure CNI plugin, which is GA, which is available as of today, you have to do a lot of planning. You have to reserve, maybe we'll be reserving a lot of IP address space for future expansion. In this case, basically you are only taking care of nodes. How many nodes I'm gonna have, and with that plan, you go to designing your network. So, for example, if you are using, if you have a /24 subnet for your AKS cluster, it can support up to 251 nodes, which is pretty large. Okay. On the other hand, in regards to, as I said, the /24 address that is assigned to each node for pod address space, that is fixed. At this moment, it cannot be changed. We don't know about the future. So this allows you to run around 250 pod on a single node. And the rest of the details are basically, simple. And once again, you can run multiple clusters in the same um, VNet as long as they are in different subnets. Just keep in mind you cannot overlap pod seeder range with the cluster subnet range. Okay, that's keep in mind, and it cannot be it cannot overlap with any of the peer VNets or on-prem. So just um, remember that. So that's something that is to keep in mind. Okay. Any questions? Okay. So in terms of limitation, as this movement is in preview, it's only limited available for Linux. A few things to come that comes into mind. You cannot use an app gateway as an ingress controller. That's an important thing to understand. So if you are play, playing with it and you want to use the app gateway ingress controller, you cannot use it. And you cannot use it for existing clusters. So if you have an existing cluster, you want to move it to CNI overlay, that is not possible as of today. And finally, you cannot deploy multiple cluster in the same subnet. You can deploy them in the same VNet but different subnet, but you cannot deploy them in the same subnet. So that's just remember that. And with that, let's do a quick show and tell. So what I'm gonna do is, yes. First of all, let me see if, okay. So first of all, let's go into the, uh, oh, okay. Here it is. Let me reconnect. So there are a few things that you will have to be doing. And one thing is you have to register the you will have to register uh, the preview for this overlay. And just keep in mind the registration will take some time. When you're registering it, it will take some time for you. In my case, it took some like 5 minutes to 30 minutes sometime. And after that, you will have to re-register the container, add-on. So once you do that, then and those that is explained kind of in detail. Let me just bring that page up so you can take a look at it. Uh, Give me 1 second. Just want to make sure that everybody is aware of. 1 second. In the meantime, any questions? Here you go. So this is what explains like how you do overlay networking, and this is the important piece. Just remember, you will have to run the preview on the extension, and then you have to register the container service feature. and that will take some time. This command will take some time to kind of complete. And after that, I mean, you have to continue checking if that is registered. Once that is registered, then then you will have to register the provider one more time. And with that, after that, you should be able to run the AKS. And let me show you the command, one of the commands that you can run, and then we will talk about different pieces of it. Um, so let's go in here and let me. Okay, so for some reason, okay, so my browser just decided to freeze for some reason. Not sure what's going on. So let me just close it and restart it back up. Okay, so let's go to portal.azure.com. Sorry, folks. Live demos are always fun. Let me just. Okay. So first of all, let me go in here and so this is how you create a cluster. Just keep in mind that you will be using first of all network plugin Azure and network plugin mode is overlay. Okay, this is your pod CDR space. So each pod, just keep in mind, will be assigned from this. So each pod will come from starts from 192.168.0.1 for first node and so on. Okay. And this is the VNet where I'm deploying node counter. It's a pretty simple. Okay. So that's how this works. And I have a let's duplicate tab. I already have created a CNI cluster. So this is the CNI cluster that I have created. And as you can see, it shows Azure CNI as the, and one interesting thing I want to show you here. Give me 1 second. Let me just go to these score. So I have created um, I have created a kubenet cluster, and I have created a CNI cluster. I just want to show you one difference just to prove the point, like um, how the networking is happening here. And so as you can see here, this is the CNI cluster. And once you create a cluster, it creates like a twin resource group where it is actually deploying all the Azure resources. So just take a look. This is the kubenet cluster, and you have the NSG, usual suspect, and you have a route table. This is the route table I was talking to that you have to have for networking to work. And this route table is not needed. I mean, that's something that is created automatically by AKS, but it's there. If you're doing it manually, you will have to create some sort of route table or routing mechanism. Okay, so that's done in the kubenet cluster. Now let's take a look at the twin for the CNI cluster. So this is the twin of a CNI cluster, and look, there is no route table because that's where overlay comes in and it takes care of all all of the networking needs between pod to pod communication. Okay, so just I just want to kind of show it to you that how it is different. The rest of the stuff is pretty much the same. It does not impact how you access it, how you run it. It basically, I think it's a step in the right direction, making the overall experience simplified, improving the performance as your pods are communicating to each other. So, I think that's something definitely worth looking at. So, uh, just want to share this. So, and once again, if we go in here, let me just once again duplicate the tab, go in here. Okay, and let's go into the CNI cluster. So if we come here and you see it's showing network plugin, same thing, CNI, but it's the overlay mode where you don't have to uh, assign us one IP address from the subnet to the pod itself. And clearly, you see here all the ranges. You have the CNI, Azure CNI, the pod range is this one, service seeder is this, DNS IP address is this, and all that. So all of these settings you can see here. So that's all I wanted to share. Any questions, please feel free to ask.
No questions
Okay,
in the chat, Naveed.
if there are no other questions, I will give everybody their 2 minute back and hope to see everyone next week for another session of Azure Power Lunch. And thank you very much.